Okay, so in this video we are going to look at conditional probability. So when we're dealing with a word problem, if the word given is mentioned, it tells us we are dealing with conditional probability. So we see here we've kind of two formulas. The more common approach is the second one here, the probability of A intersection B divided by the probability of B. But again, just depending on the context of the question, we could also use this first one. So we'll have a look at a word problem now. So we're told the school has 150 girls, 100 boys. 120 girls and 50 boys play hockey. Student is picked at random. Find the probability that the student is a girl, given that they play hockey, and then that the student plays hockey, given that the student is a girl. Okay, before we start the question, we might just set up a kind of simple tree diagram. So we have a student. They're either female or male. And then from that, either they play hockey or no hockey. And for the males also, either they play hockey or they don't play hockey. Okay, so for a female, there's 150, male 100. Of the females, 120 play hockey, which means 30 don't, and of the males 50 play hockey, which means 50 don't. Okay, so we'll just set up a simple enough maybe table out of this. So we'll create the tree diagram using the probabilities now. So we'll pretty much copy the same one. It's not going to look much different, just aside from the figures. So female or male, and then either they play hockey or they don't play hockey. Same again for the male. Okay, so for the females, it's going to be, there's 250 students in total. So it'll be 150 divided by 250, which will give me 0.6. And then for male, that means 0.4. And if they're a female and play hockey, so it'll be 120 play hockey divided by 250 again, gives me 0.48. And that leaves me with 0.52 don't play hockey. And for the males, 50 divided by 250 gives me 0.2, meaning 0.8 don't play hockey. Okay, so now we're ready to answer the questions. In part 1, we were asked for the probability that the student is a girl given they play hockey. So that's girl given hockey. So it'll be the probability of the intersection divided by the second part, probability of hockey. So the probability of girl and hockey. So we're looking for the right side, female hockey. So that's 0.48. And then the probability that they play hockey is 0.48 plus 0.2. So that's 0.48 over 0.68. Into your calculator. Gives us quite a long decimal. Again, it's common to get long decimals for these types of answers. Usually in state exams, the question will specify what to round to. We don't know, so we might just pick 4 decimals maybe. So the probability that she's a girl, given that the student plays hockey, is 0.7059. Okay, and part 2 now. Was probability the student plays hockey given the student is a girl. So it's reversed. So we want the intersection again divided by the second one, so the probability we have a girl. So we know the probability that they play hockey and are a girl is 0.48, and the probability that they are female is 0.6. Enter calculators. And we get back 4/5, which is equal to 0.8. And that's example 1 answered. Example 2 now, a little bit more work to it. We have a Venn diagram. Okay, so same process. Probability of B given C be the intersection divided by the probability of C. My intersection here is 0.2, C is 0.1. Make a bit more space, 0.1 plus 0.2. Always for Venn diagrams, just make sure you account for all of C. So that's 0.2 over 0.3, which is 2 over 3, and we'll leave that as a fraction. It's a little bit neater. Okay, and for part 2, we're asked to find the probability of C given B. So it's the probability of the intersection over the probability of B. Probability of the intersection is 0.2. Probability of B, 0.3 plus 0.2. So we get 0.2 over 0.5, which gives me 2/5. So we can leave it as a fraction or a decimal 0.4. Seeing as we did part 1 as a fraction, we'll keep part 2 as a fraction also. Again, state exams usually tends to specify the answer format. Okay, so that's that video done for the examples for conditional probability.